I'd like to talk about designing complex projects and a philosophy of design. This could be for anyone developing a new, large-scale project that impacts countries, the private sector, the public sector, and the innovation space. As we're developing the TransPod project internationally, we have to bring together a diverse set of approaches in engineering, in city building, in finance, and in really how we design our system. Let's take a look. Here we see a small model of the full-scale vehicle we're designing, and the full vehicle is called a flux jet. A TransPod line is a high-speed transportation system with flux jet vehicles and some specialized infrastructure. There are some key features. So a plasma-based power transfer system to transmit power at high speed to the vehicle. Also a flight control system and a few other key features. There are also some, you could say, more common concepts. So magnetic levitation and linear motors to propel the vehicle forward at high speed. But basically, we're designing a green, high-speed, electrically powered transportation system. But right now, I'd like to talk about philosophical principles of design. So here are 3 principles of philosophy of design that we use at TransPod designing our system. And so this is a bit unique to the TransPod system. The first one is holistic design, a convergence of disciplines. So we can say what that is not. So what that is not is, for example, if we had a group of people over here doing some engineering design, then separately we have a different group of people doing some business analysis over here, and then let's imagine we have a third group of people that pay no attention to those 2 things, and they go over here and consider the passenger experience. So with holistic design, we don't have that. We actually bear in mind all of those different disciplines simultaneously in our minds when we come up with the core concepts, the core conceptual definition of a design. Then once we're done that, we get to the second philosophical principle, which is designing from the ground up using key fundamentals, first principles. So first principles can be physics and mathematics. So unlike when one says something usually works this way, what we do with first principles is we might write out some equations, or we might consider really the fundamentals of how something works, and then we can derive what is an optimum solution. So once we've done that, then we have the third philosophical principle, which is hierarchical design. So designing from the top down with a very systematic approach. And this is what's used in the aerospace sector and in the railway industry. So this is after we have finished with the first principles and we've defined a core concept. Then we need to step back and we look at some core requirements that we specify at a very high level, and other things follow from there. So you could ask, well, what is the top hierarchical need that we define? And so we try to keep it simple. We focus on the user needs, and we focus on regulation and safety, for example. And so starting from those top items, then all the other requirements for the system design logically follows from there. And so those are very systematic processes. So now we've had some 3 philosophical points, and you might have noticed that I've talked about designing from the ground up and from the top down. So this could be compared to neuroscience when they study the brain. So there they have a convergence from the bottom and the top. So psychologists study human behavior from a very high level and work their way down to logical processing blocks in the brain. Whereas neurologists start from the cellular level and work their way up to emergent phenomena. Now, what we're designing is not nearly as complex as the human brain, but it still is quite complex. So it's critical that we follow a very systematic, rigorous approach to engineering and to design of an entire system. So what we've covered overall is those three principles, so holistic design, first principles, and hierarchical design. So those three elements are key, certainly, to TransPod. I'd like to just conclude by thinking about what are the consequences of those philosophies when we talk about different designs and we talk about standardization. And so, of course, standardization, making things more uniform, is very important. And so we just have to be careful not to rip out the heart of those philosophies and tearing out the heart of sometimes what might be very specialized designs, very unique designs that have very specific reasons they're the way they are. And so to be able to do that, I could offer two different examples of things I think would be well suited to standardization. One of them is safety. So when we're thinking about the transportation landscape, there are many different elements of safety, evacuation, structures, and so on, protocols and requirements that are really well suited to standardization in safety. The other one is a little more particular. It's communication systems, so sending data between vehicles. And definitely at TransPod, we're working on a pretty unique advanced communication system. And so the reason I say this with communication is that whenever people design communication systems, there are different layers to them. So they start with a physical layer, and there are other layers that data packets are transmitted. And so when we think about really unique designs, we can always talk about certain of those layers that are very unique and specific. But then there could be the case that some of the layers can be well suited to broadening them and making them the same across different designs or having the same features. Certain data transmissions, data packets for evacuation or emergency situations or for standard procedures. And so I would say that safety and communication could be some interesting areas for making uniform between different designs. And really that analogy can be broadened, not just communication, but other aspects of design where there are different conceptual layers where some parts remain quite unique, but other parts can be more standardized. And so send this to everyone with all of the different designs that you're working on, encouragement, and keep moving forward.